Hi class, welcome to the recording for atherosclerosis. Okay, so I know your book shows you a diagram of this, and I like it, okay, but to kind of illustrate atherosclerosis, I kind of want you to think about this, right? So here's the the lining of the membrane, or the vasculature, right? So now let's say, okay, now you have, okay, like the outside of the membrane, you have a blood vessel membrane, and then here, let's call this like endothelium. So lining of the blood vessel, okay? So now let's say, okay, you have somebody with, okay, hypertension, you know what, high lipids, okay, smoking. I actually like this because you can draw all on the side. Let's say, okay, obesity, okay, let's say, okay, bad diet, right? Let's say no exercise. Like, these are your risk factors, right? And what happens over time is that, okay, you can accumulate things along. Look, I don't like that, sorry, I want yellow because that makes me think of like lipid deposits. I don't have yellow, so you can think red, orange, yellow, whatever you want to draw for yourself, okay? I kind of think of it that, okay, this starts to damage the lining or the endothelium of the blood vessel, okay? So now you have, okay, injury. Hold on, you can't see that quite well. Okay, so let's say, okay, you accumulate things. Okay, now you accumulate a little lipid here. Okay, so we're gonna kind of do a micro shot here. So let's say that in this area, okay, you have this little vessel here. You got a bunch of lipids. Again, you have to remember what's really going on from a physiological standpoint is that you've got, a little bit of plaque formation because of, endothelial injury. But now what happens is, what do you know about injury? When you actually have injury, you have like permeability, right? You remember, you didn't learn everything in the first unit for nothing. You have permeability, then you have an increase in like leukocytes, right? You got inflammation, like all that you learn all that for a reason. Because now this is all a part of the disease process. So what does permeability mean, right? You allow fluid to be able to shift because you've got injury. You disrupt the fluid balance. Things shift based off of hydrostatic and oncotic osmotic pressure. You've got leukocytes. So in other words, now you have injury, and then you're going to think of this cleanup crew. It's going to say, hey, crew, come. We've got a problem in Houston. I need you to come clean this up. You activate the inflammatory response, and then you got, chemicals, inflammatory chemicals and inflammatory mediators that go here. They go to the site and they try to eat up things, right? But now let's say, okay, you have these macrophages that go and they eat up the lipid cell. Now, okay, sorry, my colors aren't working today. But now what you have is a macrophage, that actually engulfs a lipid inside, lipid core. So you can put yellow in there. My yellow is not working. So this macrophage that actually eats this lipid now becomes a foam cell. Okay, this foam cell releases more inflammatory mediators. And then what happens is that so before you know it, now let's go back to the vessel now, okay? So now you release more chemical mediators. Before you know it, now you attract a little bit of platelets, a little bit of, you attract other platelets, other cells, other inflammatory, and now look, you built yourself a nice little blockage, because now you also have, okay, more platelets, okay, lipid, debris, right? Whatever protein, blood flows coming along, you accumulate before now you have this nice big clot. Okay, So now you're like, okay, so now you've got this clot, and what is that going to do? Now there's a difference, okay? Now between atherosclerosis, we have to talk about plaque, okay? Stable versus unstable. And if you can recall, think about, okay, this with two different types of plaque. One is stable, one's not stable. What happens is, think about it this way, okay? You have a thicker, like fibrotic, more like a cap on the outside, okay? This one, the unstable, is thin, like lipid rich. Okay, so you kind of think about, okay, the analogy of a pimple, right? Because you know what, if you have something that's thin, like lipid rich, so like, you know, you've got like there's fluid in there, and all of a sudden, let's say all you really need is a little bit of, okay, friction, a little bit of friction and shear, okay, and you can easily break that off, right? This can easily break off. So that's what I'm saying, is that, so an unstable plaque is never a good thing. Unstable plaque, usually you have somebody who have unstable angina will progress to like unstable plaque. So versus this stable plaque here, when you know, think about, okay, the pimple, like when you give them benzoyl peroxide, you give them salicylic acid, like, you know, and you dry up, let's say that, okay, you dry up this lipid, the fluid or the lipid core, or you stabilize it, and or you give them medication, and now you make this cap, it becomes from a thin cap to more of a fibrous collagen pack. So this is harder. So you can imagine your friction and shear is less likely to be able to break that off. So that's why hence this is more stable and this is unstable. That is important, because, you know, somebody who has a stable plaque versus unstable plaque, it's a matter of, okay, who's going to progress to having an MI first? The one with stable cap or the one with unstable plaque? It's going to be the one with unstable plaque, because when it breaks off, as you know, it can travel to the heart, it can travel to the brain, and cause a problem that way. Okay, that concludes atherosclerosis with an addition of stable versus unstable plaque.